In today's lesson 1.7 and 1.8, we're going to talk about definitions, postulates, and deductive reasoning in order to help us logically solve our proofs and also come to conclusions when we're solving other kinds of problems. The first definition we're going to look at is a postulate. A postulate is very similar to a theorem, but it's going to be a true statement, but we don't necessarily need to prove it. An example of this is the SS postulate, meaning side, 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 but we'll look into those a little bit later throughout the year. The second definition is definition. This states the meaning of a term or idea. Some definitions that we've already seen so far have been array, what it means to trisect or bisect. One important thing to know about a definition is that definitions are always reversible. If we think about the definition of a right angle, we know the definition of a right angle is 90 degrees. If we reverse that and say that an angle is 90 degrees, we know, therefore, it is a right angle. One thing that you should be very comfortable with is conditional statements or implications. They usually go in the format of if-then statements. The double arrow right here refers to implies. The if part is our hypothesis, and the then part is our conclusion. Another definition is the converse. If P implies Q, the converse is Q, then P. If you take the converse of a statement, will it always be true? And are theorems and postulates always reversible? Pause this video and take a minute to state a theorem that we've already been given and rate its converse, and determine if its converse is true. I'm going to use the theorem if two angles are right angles, then they are congruent. The converse of this is if two angles are congruent, then they are right angles. We know for a fact that the first statement is true, because if two angles are 90 degrees, then they would be congruent. But is the second one true? Can you have two angles that are congruent that aren't right angles? Sure. So this is false, or not necessarily. Now try to make up your own conditional statement and its converse. Try to write a conditional statement where both the conditional and the converse are true, and another where the conditional is true but the converse is false. Pause this video and try to do both. For my first statement, I'm going to use if it is the first day of the work week, then it is Monday. The converse to this would be if it is Monday, then it is the first day of the work week. The second conditional statement I'm going to use is if you're an MUHS student, then you are a boy. The converse of that is if you are a boy, then you are an MUHS student. As you can see with the first one, it's basically a definition of what the work week is. So therefore the first and the second are true, whereas in the second statement, the first one is a true statement, but the next one is a false or a sometimes, depending on the context. So it's not necessarily true. In 1.8, we're going to look at some definitions having to do with conditional statements. The first one is a negation. The negation is simply by negating your statement. Given the statement P, then the negation is not P. You see by that tilde sign right there, that implies not. The inverse of a statement is negating both the if and the then part of the statement. The contrapositive does two things here. Contrapositive switches the if and the then, like a converse, but it also negates it, both parts, like an inverse. Take a minute and write a conditional statement. Pause the video and then write its inverse, then its contrapositive. The conditional statement that I used is, if you are at Mrs. Clendening's house, then you are in Mequon. This would be a true statement, since I do live in Mequon. Now, the inverse to this statement was, if you are not at Miss Clendening's house, then you are not in Mequon. You can see again, this is an inverse statement because we're negating both the if and the then part of the statement. Now, if we read this, if you are not at Mrs. Clendening's house, then you are not in Mequon. This is a false statement, or sometimes, because it doesn't necessarily mean that it is true. The contrapositive, again, means that you're going to reverse the if and the then statement and negate it. So my contrapositive statement would be, if you are not in Mequon, then you are not at Mrs. Clendening's. Now if we read that statement one more time, if you are not in Mequon, then you are not at Mrs. Clendening's. This statement is true. Think about your conditional statements versus your inverse and your contrapositives. You should hopefully realize or see that your conditional statement and your contrapositive, if the first one is true, then the contrapositive would be true. That brings us to our third theorem. If you have a conditional statement that is true, then the contrapositive is also true. This is an extremely important theorem to know. So if you have a statement, if P then Q is true, then the statement, if not Q, then not P, will also be true. Now take a minute and go ahead and write your own true conditional statement. And again, write the converse, inverse, and contrapositive.